I have what I call a BGO, a blinding glimpse of the obvious here for you, but and it's not the someone's usually happy to tell you where to put it, even though that may be obvious as well. What I want to go over here with you is something, it's in the CCNA studies, and it's a scenario you might have been hit with, so I just want to make sure we're all straight on this before we move to the blocking pings lab and move forward with the course. The best rule for where to put the ACL, because I see this confusion all over the net, and I get tweets and emails and Facebook emails like, well, where do I put it? And here's the thing. In the real world, you're almost always going to use an extended ACL, whether it be numbered or named. And here's exactly why. The best rule for where to put an ACL in your network is to stop it not only from going over a WAN, if that traffic would be stopped on the other side of the WAN anyway, but you want to stop it at its absolute earliest point, because that saves wear and tear on your routers. It saves time. It saves processing power, because there's no use for a router to even look in its table about where to route a packet if the packet's going to be blocked downstream anyway. Let me show you exactly what I'm talking about with this simple scenario. Let's say that this particular PC is sending data, and there's some of that data that we don't want to get to this server. Well, there's no reason, first off, let's work backwards here. There's no reason for this router to even have to see those packets if they're not going to be sent to this server. There's also no reason for these packets to go across the wide area network, which not only takes up a little processor power with both routers, one sending and one receiving, but it's also taking up bandwidth. There's no reason for the outgoing interface of this router to ever see them, because they're going to be blocked anyway. So what does that leave us, right? It leaves the incoming interface at the point closest to the host. Because when we block the packets before or as they're coming into the router on the inbound interface, they're stopped before they're ever routed. They're not even handled. So that's actually what we want. So now you're thinking, why is he going to all this trouble to tell me this stuff when I would put the ACL there anyway? Well, during your NA studies, you may have been presented with a scenario on some practice exam somewhere about where would you put a standard ACL if you had to use a standard one and you were blocking traffic from this PC to, say, this server. Well, of course, what's the one value that our standard ACL blocks on? Only one, the source IP address. We can't put the destination in. We can't put ports in. Well, again, my first instinct when I was learning about ACLs was, well, it always goes here. There's no reason to put it anywhere but on this interface. Well, unless a certification exam or a job interview or a practice exam makes you use a standard ACL. In that case, you've got to put it on the interface closest to the device that shouldn't receive traffic from that source. Why? Because if we put a standard ACL here, blocking traffic from this PC, what are we doing? We're blocking all the traffic from that PC, because we can only filter on the source IP address. We can't say don't send traffic that matches this source and this destination with a standard ACL, because we can't put a destination IP address or destination range in the standard ACL. So if that drove you crazy during your CCNA studies, I really hope this helps. It's unnecessary consternation. I think they make it a little harder than it should be. But again, with an extended ACL, whether it be named or numbered, you always put it on the interface closest to that source of the data that needs to be filtered. The packets need to be filtered. If for some reason you got to use a standard ACL, you need to put it on the interface closest to the destination. One more quick reminder here about when does the filter. Outbound ACLs are applied after packets have actually been sent to the correct outbound interface by the routing engine, but before they're put in the outgoing queue. Inbound ACLs are applied before the routing engine gets them. So that's why we really like filtering packets on the WAN, because it saves us time and processor power as far as the router goes, because the router doesn't have to route packets that ain't going to get there anyway, right? Because we're going to block them sooner or later. Speaking of blocking, that is our next lab. I may have mentioned this earlier, but I wanted to talk about where the ACLs go for a few minutes. And in the next section, we're going to talk about blocking pings, and then we're actually going to do it on a very selective basis. So take a quick breather, and I'll see you on the next video.